Example 6 brings us in a monopoly market, the total cost per week of producing a high-tech product is given by that function. And suppose that the weekly demand for this function is P equals 500 minus 2x. And so find the number of units that will give the break-even point for this product. And so again, we need to remember that break-even occurs when profit is equal to 0 or revenue is equal to cost. And now looking at this, we can see that we are given a cost function, but we are not given a revenue function. We are given the demand though. And so we need to remember that revenue is equal to the price per unit times the number of units. And so this right here tells us what the price is. This lowercase p stands for price. And so in order to get the revenue function for this thing, we can say R is equal to px. Again, revenue is equal to the price times the number of units sold. And so revenue is equal to, in this case, P is 500 minus 2x. And we need parentheses because that whole thing is multiplied by the number of units that we sell. So there is a revenue function for us. And so for part A, to find the break-even point, we have cost, we have revenue. We can go ahead and figure out when is revenue equal to cost. That will give us our break-even point, everyone. And so we will take our 500 minus 2x times x, which is our revenue function, and set that equal to the cost function that we were given, which is 3600 plus 100x plus 2x squared. And again, to get this revenue function, we took the price, which is 500 minus 2x, and I know that's a weird way to think about price, but that is the demand function in terms of the price. We take the price and we multiply by the number of units. And so it's exactly like selling burritos at the corner store. If you charge 50 cents per burrito, you charge 50 cents for one, $1 for two, $1.50 for three. You can take the price and multiply it by the number of units sold. So we do have a revenue, we do have a cost, we set them equal to each other. We're going to give them to Wolfram, and I'm going to copy and paste as much as I can to avoid having to type and maybe make typos, everyone. So let's go ahead, and there's our cost function. This is part of our revenue function. Again, what we did is we took this and we multiplied it by x to get a revenue function. We can set those equal to each other, and we get two values, two break-even points. Like we did in section 2.1, we would break even when we produce and sell 10 units or when we produce and sell 90 units. So what are we asked where to do here? Find break-even points for this product. So break-even occurs, when we produce and sell 10 or 90 units. And what we're going to see in a moment, everyone, is that the graph of the profit is going to look like this. And let's say that break even was right there. This is 10 units. This is 90 units. This right here is our maximum profit. We do not want to keep going past the maximum profit because all we do is drop the amount of profit that we are making to the place where we make $0 if we produce and sell 90 units. Again, more is not always better. We need to find the sweet spot in the middle between doing nothing or breaking even to begin with and overproducing to where we have incurred so much cost and had to reduce our price so much to sell the product that we end up losing money from where we could have made money up here. We'll continue with this problem. I believe I wrote some questions in there about that. We are looking for the level of production that will maximize revenue for this product. And so we do have a revenue function already typed up here. It's that one right there. So we're going to tell Wolfram to maximize that. And we get X is 125 and Y is 3125. That looks pretty awesome. So revenue is maxed when we produce and sell 125 units at a price of three, or no, what we need to say here is everyone, not at a price of that each revenue is maximized when we sell 125 units. Max revenue is 31,250. And it's important to recognize here, everyone, we don't care. We only care about revenue if we are talking about it in terms of cost as well. So even though we found the maximum revenue, that's great. No one cares. Now we are asked to find the level of production that will maximize the profit for this product. And so in order to do that, everyone, we need a profit function. Profit is equal to revenue minus cost. And so we had, for revenue, we created a function 500 minus 2x times x minus, and whenever we put that minus sign, we need to put a parenthesis. Cost is 3,600 plus 100x plus 2x squared. And so again, this parenthesis right here is very important because it allows us to distribute that negative sign through the entire cost function, not just part of it. Let's see what we've got in Wolfram right now, and I'm going to end up doing quite a lot of copy pasting for this one, I think. Here's our cost function. So there's revenue minus cost. And so for a profit function, we get kind of a wacky alternate forms is what I'm looking for, everyone. I'll try and find one, or expanded form is the one that I'll choose this time. Our profit function is equal to negative 4x squared plus 400x minus 600. Okay, so I'll go ahead. I think I can copy and paste right out of here. And if I really wanted to, everyone, I could. I don't think I can actually. Oh, I can click it, and then it will bring it up there. I could have typed maximize in front of what I had written for revenue minus cost, but I prefer to go through this process and make sense of it a little bit better. So this is our profit function, everyone. You can see that our profit here starts negative. That's because we have fixed costs that we have to pay before we produce anything. We start making stuff and selling it, and we start making money. Everybody's happy. Everybody's happy, happier, 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 happiest. Now we are working and making products and selling them for no reason. We are losing money. We are getting sadder, 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 and now we're out of business. So we want, again, to look for this sweet spot right here, everyone, and we can see that it is producing 50 units and selling them at a price of $9,400 each. No, I'm sorry, not producing 50 units will maximize profit at $9,400. So producing and selling 50 units maximizes profit at $9,400. Next, part D, we got two different answers for B, for C, B, and C. A, B, C, D. Oh, I was still answering C there, so I need to take this off of here. There we go. Crazy morning, everyone. So let's take a look for part D. We got two different answers for B and C. So B says that we should produce and sell 125 units to maximize revenue. C says that we should produce and sell 50 units to maximize profit. Which one of those should we do? Duh. Do what it takes to maximize profit. We don't care about revenue. We are only going to produce 50 units. Only produce and sell 50 units. No more. So again, everyone, maximizing profit with 125 units sounds like a great plan. But by doing that, our costs go up so significantly as well that it causes our profits to drop. We don't care about revenue. We don't care about cost. We care about the relationship between revenue and cost, which is profit.